Hello everybody, this is Biswajoy Chatterjee. I'm the Vice Chancellor of University of Engineering and Management, UEM Jaipur. And I'm back with another puzzle today. What is that? The 8 balls and a weighscale puzzle. And what does that read? You are given a weighscale. What is that? A machine like this, a weighscale. You are given a weighscale. Now, this machine, as you can understand, can detect the heavier weight or the lighter weight so easily when you put on weights on both its sides. You are also given 8 balls. These are the 8 balls given to you. One of these balls is heavier than others. That is, out of these 8 balls, all are equal weights, but one ball out of this is heavier than the others. So you can understand that the problem is you have to detect that which ball is heavier, but within how many weighings? Will you need 4 weighings? Will you need 5 weighings? Can you do it in 3? Can you do it in even lesser? Is it possible? Within how many weights can you tell me which of these balls is heavier than the other balls that you can see on screen? So that is what we are going to solve today. So the first way of doing it can be very simple. You have already started guessing. Some are guessing, okay, within minimum 3, within minimum 4, minimum 2, whatever you are guessing within your mind, you're thinking of solutions. But I will go approach this solution one by one. Say, for example, you take up like this. You take up the ball 8 balls like this and start from here. You select 2 balls. Now, out of these 2 balls, what you will do is you will put these 2 balls into the weighscale. And as soon as you put, you see one of the positions, one of the balls go down. This one goes down over here. What does that mean immediately? I will take very quickly a pen to show you. Suppose this ball goes down. This portion of the weight goes down immediately. What can you say? You can definitely say that this ball is heavier. How many weighings did you need? You needed only 1 weighing. Definitely this ball is heavier, this ball is heavier. And how many weight did you need? Only 1 chance you detected it. But this is the best case. This is the best case. In the first first 2 balls that you selected and you put into the weighing machine, immediately into that you detected that one of the ball is heavier. So in the best case, definitely yes, in 1 chance it can be detected that one ball is heavier in the best case. But we need to solve the problem with minimum weighings in the worst case. So in the worst case, we go back to the initial point and we can say that in the worst case, if we select these 2 balls and put it, then both of them will weigh equal. Now, can you say that any of these 2 balls is heavier? No. But you can say one thing, that this ball is not the heavier one, this ball is not the heavier one. These 2 balls are equal in weight, they are not heavier. So you can easily leave out this ball. You can easily leave out this ball. You are left out with 6 balls. Can you say number of balls left right now with you is 6? I've got rid of those 2 balls. So 6 balls are left and number of weighings done is 1 till now, but you could not detect yet. Let me see how many weighings you will need. I select the next 2 balls and put it into the weighing machine. Once again, to our disappointment, suppose these 2 balls weigh equal. So definitely this is not the heavier ball. Definitely this is also not the heavier ball. So I can get rid of this. I can get rid of this. I can get rid of both these balls. What can I say? I'm left with only 4 now. This 4 I am left with now. So this is the position now. Number of balls left is 4. Number of weighings done is 2. Let's proceed from here then. I select the next 2 balls. Put it in the weighing machine again. Again, to our disappointment, they are equal. This and this. Both of them are equal in weight. So none of these 2 balls are heavier. I can say I get rid of this ball. I can say I get rid of this ball also. I get rid of this ball also. What am I left with? I'm left with 2 balls only. I'm left with 2 balls only. These 2 balls I'm left with. 3 weighings done already. Let me go ahead and say this is the position. I select these 2 balls. What will happen if I put it into the weighing machine? Definitely one of these balls will be heavier, because it is given that out of the 8 balls, one of these 8 balls is heavier. So if I put into the weighing machine, this time it will show, yes, one of the balls is heavier. Which one is it? This one it is. Definitely this ball is heavier. So I can say, yes, definitely this ball is heavier, and number of balls left is 0 now, and number of weighings you have done is 4. Within 4 weighings, you could say that which ball is heavier. The heavier ball found in 4 weighings. So obvious question is, can we reduce the number of weighings? Can we do it maybe in 3? Can we do it maybe in even lesser? Is it possible? Check out now. I'm left with 8 balls. So number of balls left is 8. What is the number of weighings to be done? What I do this time is somewhat like this. I select 4 balls and 4 balls, group of 4 balls togetherly I select. And I put them togetherly into the weighing machine. I will put these 4 balls in one side. I will put these 4 balls in this side. One of the side will definitely go down because one of the balls is heavier. One of these balls is heavier. So the weight of one out of these 4 balls group will be heavier than the other group. I put it and see something like this. What can I say? That the heavier ball is present over here. The lighter ball, all these balls are lighter. The heavier ball is not present over here. The heavier ball is not present over here. The heavier ball is present over here. So I can say the heavier ball is definitely present here. See the arrow on this side, the heavier ball is present. Now can I get rid of these 4 balls? Because I know that the heavier ball is not present in these 4 balls. Yes, we can get rid of these 4 balls now. I'm left with only 4 now, and keep these 4 balls. I'm left with this 4. I can say number of balls left is 4. Number of weighings done till now is 1. Which 4 I'm left with? I'm left with these 4. Let's continue. So I'm left with 4 balls, 1 weighing done till now. What will I do now? I select groups of 2. See, one of these 4 balls is heavier. So if I put this in one side and put the other 2 in the other side, then definitely again one of the side will go down. One of these 4 balls is heavier. So one of these sides will definitely go down. Is not it so? I put it. Yes, one of the sides goes down. What can I say? The heavier ball is present over here. See this. The heavier ball is definitely present here, no doubt. So the heavier ball is not present here. Can I get rid of this 2 and say that we are left with only this 2 to find which one is heavier? Yes, we can get rid of these 2 balls and keep these 2 balls. Only within these 2 balls the heavier ball is present. So till now, number of balls left is 2. Number of weighings done till now is 2 only. So this is the position. Left with 2 balls, Which of these is heavier? One of these is definitely heavier. So I select them one and one. Put this on one side and put the other ball in the other side. What will happen? One of them will definitely go down. Yes, it happens. What can you conclude? Yes, you can now conclude this ball is the heavier ball. The heavier ball is definitely this one. So you have detected the heavier ball in how many weighings? In 3 weighings. We get rid of this ball and say that the heavier ball is this one. This one is the heavier ball. How many balls left now? 0 balls. How many weighings did you need? 3 weighings. Job done in 3. In the previous way, we needed 4. Now how many do you need? You need 2. You need 3, sorry. So the heaviest ball found in 3 weighings. The $1,000,000 question again is, can we even reduce and do in 2 weighings? That's the biggest question at our hand now. Do you think that we can even reduce and do in 2 weighings? Is it possible? See how we do. It is possible. We can do in 2 weighings. 8 balls, heavier ball can be detected in 2 weighings. Let's see how. I select 6 balls at a time. These 6 balls I select. I leave out these 2 balls for the time being. These 2 balls I leave out. I only deal with these 6 balls and divide it into groups of 3 and put it into the weighing machine. Let's see what happens. I put these 3 into the weighing machine. What happens is the weighing machine stands still. Suppose it stands still. I can say heavier ball is not present here. Heavier ball is not present here. These are equal in weight. But the heavier ball is definitely there. So the heavier ball is definitely present in these 2. What can I say? We can remove these 6 balls. The heavier is not present here. And what can we say? The heavier ball is definitely one amongst these 2. Is not it so? If it goes like this, so number of balls left in this example is 2. Number of weighings done is 1 till now. But this is not the only case. Let's see, let's proceed. However, in this case, I can say I put those 2 balls into the weighing machine. Definitely one of them will be heavier because one of the balls is heavier. And in the previous 6, the heavier was not present. So within this 2, one of the balls is heavier. I can say the heavier ball is definitely this one. I get rid of that ball. I get rid of this ball. I get rid. And I can say this ball is heavier. We are left with 0 balls and we could do it in 2 weighings. The heaviest ball found in 2 weighings. But this seems to be a better case. If we go back 2 steps and go back to that step where we picked up the first 6 balls. You remember I picked up the first 6 balls, left out 2, and what happened was those 6 measured same. If it does not happen that way, if one of these 3 balls turn out to be heavier than one of these 3 balls turn out to be heavier than, then what you can do is you can say the heavier ball is present over here. I can get rid of these 3 because these 3 do not contain the heavier ball. Even I can get rid of these 2 because the heavier is present here. So the heavier is definitely not present here. See what? We can remove these 3 balls. Also, we can remove these 2 balls. Remember, these 2 balls we can remove also. And say we are left with only 3 balls. We are left with 3 balls and 1 weighing done till now. So 3 balls, 1 weighing done. Now you are left with only 1 weighing. If you have to do it in 2 weighings, in 1 weighing you have to say which of these 3 balls is heavier. How to do? Go ahead with this 3. We are left with 3, one weighing already done. What to do? I select 2 of them. I leave out one. I don't use this. I don't use this one. I use only these 2 and put them into the weighing machine. Suppose it happens that it goes like this. You immediately say that this ball is heavier. You can say that this ball is heavier, and you detected in 2 weighings, 0 balls are left now because this ball is heavier. You can also get rid of this ball and say that only this ball is heavier, these 2 balls are not. So within 2 weighings you could do. But then again, it seems to be a better case. What if the heavyweight ball, yes, it is found in 2 weighings, but in the previous step, what if when I selected the 2 balls and left out one, you remember we were left with 3 balls and we had done 1 weighing, so we have to do it weighing, we have to detect which ball is heavier. I select these 2 and put it in the weighing machine and see that these 2 measure equal. Then what? Then I can easily say that this ball is not heavier, this ball is not heavier, but one of these balls is heavier. So definitely this is the heavier one. You have detected the heavier ball. Again, 0 balls left. Only in 2 weighings you detected that this ball is heavier. The trick is leaving out this one ball. If the other 2 balls show the heavier weight, it's done. Even if they don't show the heavier weight, you know that this ball is heavier. So again, you have done it in 2 weighings. So the heavier ball again found in 2 weighings. So even in the worst case, within 2 weighings, you can say that you have found the heavier ball. In 2 weighings, the heavier ball can be found. Thank you. And I will challenge the programmers for the next step. Choose out and write a program to solve this puzzle. Thank you so much. Thanks from Biswajoy Chatterjee, Vice Chancellor, University of Engineering and Management, UEM Jaipur.